Right, we start at the beginning in the olden days, the earliest forms of cryptography. The Caesar cipher is the oldest example that I'll discuss. Then the simple substitution cipher. Look at basic cryptanalysis, and then we'll move on to more advanced things, starting with Enigma. So the Caesar cipher is attributed to Julius Caesar. It probably was used before that already, and it simply means that you shift all the letters in the alphabet down or up, doesn't matter. Ones that fall off the edge there you put at the front. And so if you want to encrypt something, you simply say, I have a letter A, I'll substitute that by W, I have a letter D, I'll substitute that by Z, etc. So the plain text, my hovercraft is full of eels, becomes a ciphertext which is slightly less pronounceable. Note that we only use uppercase letters and we don't encrypt spaces, and this is significant. Brute force cracking, assuming the enemy knows which sort of cipher you're using, and you should always assume your enemy is as clever as you, just requires 26 attempts. Well, 25 if you discount using a shift of 0, which would be rather pointless. Because the only thing you need to know is indeed the amount of shift. Okay, you can go one better. 26 attempts is not that much, especially nowadays on computers. Even back in Caesar's day, 26 attempts, not too much. You might want to do better. So what we can do is we do a random permutation. We randomly shuffle the letters in the alphabet. And there are 26 factorial combinations. And so my hovercraft is full of eels, is again produced a weird ciphertext. And we need 4 times 10 to the 26 attempts, which generally speaking would be okay. If you use brute force. However, okay, so we have a Caesar cipher that requests at most 26 guesses. You can speed things up by counting symbol frequencies, and there's a website in which you can do that. And so you know, if you know that there's a fixed substitution table, it doesn't matter if it's a Caesar cipher or some others, then you can often guess what is the letter E replaced by, because that's the most common. So in the Caesar cipher case, if you know that E is the most common one, you look for the most common symbol, that gives you the shift, you're done. A fixed substitution cipher can be cracked in the same way, but you need more symbol frequencies. So the letter N, the letter A, the letter T, etc. are common letters. The letters X, Q, etc. are rare. So that gives you information. And the other thing is, you have not encrypted the spaces, so you know the lengths of words, and that gives you an extra tool to say, all right, I know the language he's using. In Caesar's case, that would be Latin or Greek. Educated Romans often used Greek as well. But that's just a limited number of guesses, and you can then work out what he's probably being saying. Once you've got a series of letters in place, then the others generally follow. Fixed tables are therefore a liability, and that is exactly what Enigma was about. What happens here is that if you press a button, that through a plug board where there are settings and a series of rotors where you have settings, this letter is replaced by another letter which lights up, and the rotors are shifted so that in the next iteration, the next key pressed, you use a different table, and that made it so hard to crack.